So this is the 30th session on relative velocity. So in this session I'll take up two problems on relative velocity collision in two dimensions in which the relative acceleration between two moving points is non-zero. Okay. So this I'll take up this in this session. Okay. First I'll write down the question. P1, P2, P3 and Pn are n points. Are n points which are initially situated at the n vertices of a regular polygon of side length L. At t equal to 0, these n points begin to move simultaneously with equal constant speed v. Such that velocity of P1 is towards P2 and velocity of P2 is towards P3 and velocity of P3 is towards P4 and so on, and velocity of Pn is directed towards P1. Alright, now to find after what time will n points meet. Okay, after what time will these n points meet in terms of L, V and N. Okay, this I'll write it. Okay. So I'll draw the diagram. So this is point P1, this is point P2, P1, this is say P2, this is say P3 and so on. This is say P4 and so on. Okay, all these sides are equal. Okay, this is last point Pn. Okay, since n is not specified, so we cannot draw the exact polygon, just an approximate polygon. Okay, this is the center O of the polygon. Okay, now again before solving we will make two observations as we did in the previous video for the case of three particle system initially at vertices of an equilateral triangle of side length L. So three observations we'll make here. Two observations, sorry. First, the 3 points will again meet at the center O of the polygon as it was in case of triangle. Okay, the 3 points will meet at the center say O of the regular polygon. And second observation, at any instant of time, these endpoints will form an n-sided regular polygon whose center coincides with center O of the original polygon. At any instant, these endpoints will form an n-sided regular polygon, n-sided regular polygon whose center coincides with center of the original polygon. Okay. So this is the, okay, fine. I'll grab it, okay. So now again this problem can be solved by three methods, as was in the case of triangle in the previous video. I will solve it only by one method, okay. So the path of P1 will be something like this, path of P2 will be something like this, path of P3 will be something like this, path of P4 will be something like this, and so on. Path of Pn will be something like this, and so on. So this is the P1 at time t, this is Pn at time t, this is P2 at time t, this is P3 at time t, this is P4 at time t, and so on. And so on, okay. This is the common center of all the polygons. So P1 has come here, P2 has come here. Suppose S is the side length of the polygon. Now velocity of P1 is towards P2, velocity of P2 is V, that is towards P3, and so on. Now this angle alpha we can determine. So this angle will be equal to pi minus alpha from geometry. So now ds by dt, s is the distance between the two adjacent points at some instant small t after the beginning of motion. So ds by dt is rate of change of s with respect to t. S I have just mentioned, it is the side length of the regular polygon at time small t. S, and so on. Alright. This will written as rate of increase of s minus rate of decrease of s. Now see, this V has a component along this direction and component normal to P1 P2. Component of V normal to P1 P2 will not have any effect on s. S will be affected only by the component of velocities of P1 and P2 along this line P1 P2. So component of V along this line is V cos pi minus alpha, and that tends to increase s. It is directed in this way. It will tend to increase the value of s. So and this V is directed towards P2. This V will tend to decrease s. So rate of increase of s will be V cos pi minus alpha. This will be equal to rate of increase of s. So ds by dt is equal to rate of increase of s. That will be equal to V cos pi minus alpha minus rate of decrease of s. Now this V is directed towards P2. It will tend to decrease s. So rate of decrease of s will be V. Now V cos pi minus alpha is known to be from trigonometry minus V cos alpha minus V. That is equal to ds by dt. Now how do you find the value of alpha? Alpha is the angle between two adjacent sides of this regular polygon. So I just draw the polygon here. See, like this. This is center of the polygon. This angle is alpha. Angle between two adjacent sides of this n-sided regular polygon, they are all equal alpha. This is the center O of the triangle. It's a regular polygon, n-sided regular polygon. All the sides have equal length. So all the sides will subtend the same angle at center O. So this angle will be equal to 2 pi by n. Now, if we drop a normal, this is right angle. This is 2 pi by n. This is the bisector of this angle. So this angle will be pi by n. So this angle will be equal to pi by 2 minus pi by n. This will also be equal to same angle. So alpha will be sum of these two angles. So alpha will be written as pi by 2 minus pi by n plus this angle. This angle will also be same, n-sided regular polygon. Pi by 2 minus pi by n. Pi by 2 and pi by 2 add up to pi minus 2 pi by n. So alpha is equal to this much. Now we substitute alpha in this formula. So we get, I draw the line here. So ds by dt is equal to minus v cos alpha is pi minus 2 pi by n minus v. Now cos pi minus 2 pi by n is minus cos 2 pi by n. 1 minus is here also. 2 minus plus. So ds by dt is equal to minus plus v cos 2 pi by n minus v. So now I take dt the shift at that side. V into cos of 2 pi by n minus 1 into what? dt. Now I integrate this equation on both sides. 0 to t. Initially s was l. Finally s becomes 0. On integrating it, this becomes minus l. V and these are all constant quantities, they come outside the integral. Minus v 1 minus cos of 2 pi by n into integral dt 0 to t is just t. So on solving this we get how much t we get? L by v into 1 minus cos of 2 pi by n is therefore the required answer. So the end points will meet at the center O of the polygon where t is equal to L by v 1 minus cos 2 pi by n. Alright. This formula can be used as a standard formula. इसको आप लोग याद कर सकते हैं. You can remember it. Okay. So t हो जाएगा L by v 1 minus cos of 2 pi by n. So the end points will meet at the center O of the polygon after this much time. Alright. This is a bit. Alright. So this problem I have discussed, alright. So for different cases we get different corresponding value of t. For n equal to 3, that is equilateral triangle, t becomes L by v into 1 minus cos of 2 pi by 3. Cos 2 pi by 3 is cos 120 degree, that is minus half. L by v into 1 minus 1 by 2. L by v upon 3 by 2, so 2L by 3v. Same answer as we obtained in previous video for triangle. For n equal to 4, that is the 4 particles are initially at the square, t will be equal to L by v 1 minus cos 2 pi by 4. Cos 2 pi by 4 is cos pi by 2, 0. This term goes away. So time becomes L by v. For the case, this is the result for the case of 4 particles initially at the 4 vertices of square of side length L. For n equal to say 6, that is the 6 particles form a regular hexagon of side length L. Time at which they meet will be L by v 1 minus cos of 2 pi by 6. Cos 2 pi by 6 is cos pi by 3, that is cos 60 degree, that is half. So L by V into 1 minus half. So it becomes 2L by V and so on. Is in this way, okay? For n equal to 8, that is the 8 particles form a regular octagon. So T will be equal to L by V 1 minus cos of 2 pi by 8. L by V 1 minus cos of pi by 4, 1 by root 2. Alright, fine. N equal to 8, this is the time. N equal to 6, this is the time. N equal to 4, this is the time. N equal to 3, this is the time. And so on. Alright. So this video I close here, okay? Next video I will discuss again new problems, okay? Fine.